charger phone working? No, can reach. I'm not use it. I still got battery.
So again, copy the correct lab setup. Let's find lab setup actually in the module, right? You actually have a C plug.c. So you should copy the correct, or you should actually share the correct lab setup for today. Of course, the Docker Compose YAML file. If you look at it, you have an infected, 150, a user 1, a user 2. In the victim, there's one part that the sync cookies is actually turned off. So I think that's not. That means the protection is actually turned off for this. Okay, again, let me copy to the correct folder for my case. So a good practice is always check whether you still have your Docker container, right, still sort of like existed in your seed machines. If there are any, right, just run the Docker Compose down. So sometimes you may find that they'll actually ask you to do some additional options to cleanly, right, actually remove all those containers. Right, after that, just do the usual thing, the Docker Compose up. So if you look at the environment for today, right, the lab environment, this is what we have. We have an infected, we have like 3 machines. We have a victim, the victim is 10905. The attacker is having the same IP address as the VM, so the network port is actually a fault. So the IP address should be 10901. Okay, then the other two, user 1 and user 2, the IP address is .6 and .7 respectively. Right, again, the usual things of the container setup and command, but this part is actually the same as your previous step, more or less the same. Right, about a container, expected container, you have a chat folder, again it's volume, it's running on host mode. So it has the same IP address as the host. Then we are going to use telnet, which we have already tried before. So again, when you log in, the seed password is DES, reverse. Okay, so you're going to do sync flooding extension. So sync flooding is a form of DOS like that. It's actually not just sync flooding, you can actually do async flooding. You can do other types of like flooding using the different threads. Like example, one of them is actually an expert that actually turn on three threads. Sync flooding is special in the sense that you will send many sync requests, but the attacker do not finish the three-way handshake, so we call it a half-open connection. Attacker either use full IP address, alright, or they do not continue the procedure. So if they can start the victim's queue, that is fast enough. The victim will not be able to take any more connections based by service. This is the normal TCP and three-way handshake. This is the attack. So in the normal TCP three-way handshake, you will see a sync. You'll see client send a sync. Server send back the sync acknowledgement. Then client actually reply back with acknowledgement. But then in the attacker case, the attacker actually send a lot of sync packet. When the server responded, alright, attacker very often is random IP, it will not send back the acknowledgement, and this will open up the connections here. It will take a while for it to sort of like clear off. So when the queue is full, the victim cannot take any more connections, then legitimate connection cannot be made to the victim, right? The server in this case. You can actually just capture the TCP three-way handshake first, but many open up terminals. So I will log into the victim, which is SS. Okay, so the port is listed. Then I'll go to the user one, right, which is B3. So I'm going to turn on my Wireshark. Alright, we're not doing any attack, we just want to see the TCP three-way handshakes. So I turn on the BR. Alright, start capturing this on the BR's interface. Alright, the BR dash interface. Then I do a telnet from the 10906 to 10905. So I log into the remotely controlled 10905. So back to the Wireshark. If I scroll all the way up, I should be able to see the three-way handshake which is on here. Alright, this button. You know, see you have a sync. So 10906 send to 10905, this is a sync. The 10905 reply back to 10906 sync acknowledgement. Then 10906 reply back to 10905 from acknowledgement. So user one to victim, victim reply back to user 1, user 1 reply back to victim. Sync ACK. In the sync flooding attack, right, the attacker will send a lot of sync packet without complete the connection, which is without sending the third packet, which is the acknowledgement packet. Alright. So this one is not doing any attack, this is just to show the trigger handshake. Okay, that's 3 packets. So let me just terminate this by exit, alright, exit from the user 1. Go ahead to look at the net guide, alright, I'm actually at stage 4. So here actually said that the size of the queue actually have system-wide settings. In Ubuntu OS, we can check the settings using this command. So we are going to look at the victims. For this case, we run this command. Okay, I think you need some options. Let me just check it out first. Okay, this is checking. Alright, just checking this is actually file 1.2. This is file 1.2. We possibly want to reduce it. That's actually a CC maximum backlog. Okay, should be that. Okay, let me just try it out. I reduce the default 512 to 128. So the data is actually easier to see the impact. So I'm actually running the command that is actually stated in the big ball, alright, on the left guide, but with a dash W option, right, with a dash W option. So just now when I checked the victim is 10.05. It's actually having the maxing backlog of 512. So you can actually take 512 connections, but I want to reduce it, so reduce it to 128. Running this command. Alright, so it's actually the same command just with the option that is W. Then just put okay, actually you cannot have space. So just now when I put a space, it gives me an error. So If you don't do this, it's also okay. Later the C program should be able to fill out all the 512 connections also. Cosmic take just a little while longer. But I don't want to reduce it too little so that just to show you that when you run the Python program and the C program, there's actually a difference. Depends on how fast you can run. Okay. So again, this one is actually not mandatory. It's up to you. You can use a netstat-NAT to check the usage of the queues. If there's a half open connection, it's actually sync reset. If two-way handshake is finished, alright, it's actually established. So if I go back here to check netstat-NAT, there's actually nothing. Alright, there's actually nothing. If I go back to telnet from the user one again to just 15. This is actually what happened. Established, right? One connection established. So in here, how do you look at this? Is the local address because you are a victim is 10905. Telnet port is 25, right? Telnet service is 23. Then this is the user one, foreign address, right? 10906. Then this is the port, right? The dynamic port that is given by OS, right? Every time you have a different. So this IP address together plus the port number is really quite a socket. If I exit, close the connection, you see the state actually changed to time with. Then after a while you'll be gone. Time with. After a while you'll be gone. Alright, so I may not do all the experiment for this one because the data net is actually even more interesting than this one. So by default, the Ubuntu sync flooding countermeasure is turned on. So it's called sync cookie. So if the Ubuntu, alright, detects that it's under sync flooding, like that, alright, you will actually sort of like stop the attack. But then in the victim server container, we have turned it off. To display the cookie, you can actually run this command. To turn on the cookie, which by default is already turned off, right? You run this command. To turn it on, so later we will try turn it on later on. This command. So we will not be doing this since the default is already turned off, right? In the YAML file, it's under this button. Okay, that's what I leave it to you to read. Task 1.1, alright, launching the attack using Python. So there's actually a code given which is actually here. Alright, we have intentionally left out some essential data. So it sends out spoof TCP sync packet, randomly generated source IP address, source port and sequence number. So for this case, alright, you are actually sort of like import the get random bits from the random. So your destination is actually your, this one is actually pretty easy. Your destination is actually your victim. Destination port is your telnet port. Right, telnet port. So it's 23. Thread is 6. You can just copy this whole program, just clear out this two parts. While true is actually doing the source, alright, so it will capture, sorry, no, it will not capture, you just generate random IP address. It will generate random source port, and it will generate random sequence number, and you will send it out. So let the attack actually run, actually only 1 minute, you will not, it should not work, and try to telnet into the victim machine. See whether you can succeed. So very likely your attack will fail. But before that, because I already telnet, so okay, we are not using VirtualBox, so I will be looking at this. I need to remove, okay, I don't want to reduce further of the size of the queue if you want to set it up. Let me see why it is. I want to flush the TCP matrix. Because if you already make a connection before, right, you will remember it. So even under sync like that, you still can go in. So since I already telnet, I'm not sure whether this is still there. Let me just check. It's still there. Okay. When I run the IP TCP matrix, it still shows that just now when I telnet of 10 the connection is still there. So I'm going to flush it. Alright, I'm going to flush it. IP TCP matrix flush. Right, flush it, then show it again, it's gone. If you never telnet before, then it doesn't matter. It should be empty. But if you have telnet before, then possibly the cache is still there, so you just flush it. Alright, if not, the attack will never work. But by default, because I set to 128 for the backlog, 128 connection for the backlog, and it's likely that your Python will not be running fast enough. Okay, so I have let write part 1, the Python file. Let me also copy this to the volume folder. So let me go to the seed attacker, which is DD for my case. Okay, I think let me just show you this code first. just a piece of code. Basically, the info that you add in is actually here, right here. It's actually the same as your lab guide. Basically, just these two parts. Putting 10905 and putting the destination port 23. Okay. Alright, so we are doing lab 5, the very initial part of tab, the task 1.1. We are trying to do a sync flooding attack from Python program. Once you have done this, I can actually run it in the attackers container. Alright, in the meantime, let me just stop my Wireshark and recapture it. To be able to capture the VR interface. So I run it, go back to look at a Wireshark. You can see that now the source IP address is like the random kind of IP address. You can just see all the random IP address. It's actually doing just pull out any one of those random ones. Just look at the port, alright, it's actually simplex. Then when the victim actually reply back sync acknowledgement, because there's no such IP, it's not possible to reply back with ACK. So you will use up the connection, alright, you use up the connection. So, alright, so far it's actually for my case, it's like 2,000 over packets. Right, it actually looks fast, but it's actually pretty slow. It's pretty slow. It looks like a lot of packets, but this is considered very little. You can actually open up the victims at the moment, maximize the terminal. Run netstack-NET. You see you have all this sync receiver, right? Sync receive. Okay, sync receive. Because for my case it's like having like backlogs of 120, right? 120. So you should actually read the instructions. It actually has some reserve also, right? Has some reserve also. Which that's what I leave it to you to read that. Alright. So I let it run a while. Then I try to tell it from the 10906. Seems like 10906 is hanged. Let me open another one. Alright, so I tried to tell it 10905. So it seems like the attack is actually sort of like, oh, okay, slow down. Alright, it slowed down, but it didn't actually sort of like stop it. So I still can see the login port. I still can log in, although it do slow down the process a little bit. Alright. Which is actually just faster. this one, right? Let's say page 5, let the attack run for at least 1 minute. Try to tell me in the victim machines whether you can succeed. Very likely that your attack will fail. Okay, so multiple issue. So see the TCP cache, alright, we don't have this VirtualBox issue. We are not doing 2 VMs. Size of the queue, alright, for my case I changed it to 128. But there's actually something that we reserve, but they call it proven destination. So this one I leave it to you to read. This one I didn't do, I didn't want to do that, I want to move on to the next experiment. Because the later experiment is more interesting than this one. So if you want, you can try out on your phone. If you put the half open connection queue very small, you will likely succeed. Then remember to run the flush. After you log in, you exit. Then remember to sort of like flush it. And what I want to do is I want to stop it. Control C. I want to stop it. Alright, see my terminator is like the victim machines and the user one machine is like 10 of each. So hopefully you can recover. If not, I will just stop it and run again. So far, I can see like less than 15,000 packets. Right, again, it looks like a lot, but it's actually very little compared to the C program that we are going to run soon. Okay. Alright, so I leave it to you to read all this at the moment. I just want to go to ICMP's TCP metric. Right. But I must be able to go into my victim first and at the moment. Alright, next. Alright, going from my terminal. Here I want to flush it so that you will not infect the later experiment. Okay, it seems this part actually hang until I can't go in there. Yeah. Close it. Alright, so this is the Python, right? This is Python. I'm going to move on to the C, alright? So there's some mentioning of using the open up multiple like AD user 1 and user 2 together to run the attack together and see whether the attack will be successful for Python. That part I leave it to you. And to reduce the backlog, alright, I leave it to you to try out also. But I'll move on to part 1.2. Launch the attack using C. So all the issues of the attack being not successful mentioned in part 1.1 can be resolved. If you can send your SYN packet fast enough, so we can run it using C program. we provide a C program called syncflat.c. You will compile it, alright, so you run this command to compile it. You go to your modules folder, is actually under your modules folder. Run the GCC command. Alright, you actually have like the syncflat here. You can actually take a look at the code if you want to. Alright, it's up to you. To launch the attack, right, you run syncflat together with IP address and together with the port number. Alright. But before I do that, let me just open up another tab to go into the some problem. Right, to go into a user one machine. So again, before I run the attack, let me just turn on the Wireshark first. So it's running, it's actually sending out a sync packet. Go back to Wireshark to check. This is the speed that is much faster than Python. So you see now it's actually like almost like a million packet. So this is unusual, right? It's unusual. So you can see that the C programming is actually much faster than Python. Right. But be careful, this was a real DOS attack. Don't run this on like a real production website. Alright, and don't run this on your neighbor's network. Or it's illegal. Run this on your own machine. Alright, now go back to Telnet again. So you see it will stuck there for longer. Or it may not even come out. So that means that you have done the sync flooding attack on the machine, or you still can do it, alright, but it's longer. Okay. But then now the packet is actually much more, alright, than sending out Python. Alright. I still can do it. It's not as under the reserve connection. Let me just try again. as you run longer, it actually eat out the connections. So it's harder for a legitimate user like, for this case, I'm actually, D3 is user 1, I'm actually user 1. It's actually getting harder for user 1 to try to telnet to the victim. So it was stuck there for longer. Right, so things like this successful. So what I'm going to do is stop this. Alright, if not you'll hang my whole machine. I think I'm too late. Okay, so don't run it too long. Because we are doing everything in the VM and we use model containers, so impact the whole VM machine. If you can't get it back, alright, this was a successful attack. And it also successfully hang my own seat over to just reset it. Okay, so you try it yourself. I'm not going to run it again. Alright, I'll wait a while then move on to the next task. Right. Okay, the other experiment that you can try is you can actually enable the sync cookie mechanism, then run your attacks again. How do you enable your sync cookie mechanism? You go to this part, this one, or you turn on the sync cookie, this command, in your page form, right in the page form. So this one I leave it to you to try. The attack should not be successful. Alright, it should not be successful. Okay, it's good that nowadays we can use container to illustrate this. But last time when we actually use VM machines to illustrate this, usually I will use the NAT machine because it maintain the whole physical machine. Then it's just got to restart the whole machine. Press the on-off button. Alright, so you try out first, give you some time to try out before I move on to the part 2, the TCP reset effects on the telnet connection. try out more about like different types of front. You can try like TCP's the acknowledgement front, right? The TCP front. You can try actually the reset front. You can actually try other threads and see actually what happens by, because you have a code, you actually have a C code. You can just change the start the TCP headers. You can just try the same thread, you try changing to other threads and you can actually see what happens. But that is actually up to you to experiment. Okay, the other attacks that we are going to do is the reset attack. So TCP reset attacks on the telnet connections. So this attack, you can actually use it to terminate and establish a connection. So you use like terminate the telnet connection. So the attacker can actually spoof a RST packet right from A to B. So this will break the existing connections. So we need to construct the TCP's reset packets correctly. So this task will launch this attack from the VM. You can actually launch it from the expector also, but you can actually launch it from the VM. To break an existing telnet connection between A and B. So to simplify the length, you assume that expector and victims are on the same length, alright? So expector can observe the TCP traffic. So to launch the attack manually, you got to, okay, there's a command here from your computer. So you got to understand the desired IP and port numbers before completing the script. So you got to use SCAPI to conduct this attack. So there's a skeleton code. You need to replace all this, right, with the actual values. You can actually get them using Wireshark. This one, right, it may not be successful the first time that you do this, especially if you have like the wrong things in your, like your port numbers or even the sequence numbers. So this piece of code is actually getting to send a spoof packet. Right, to send a spoof packet to the destination, take that as source, to send a reset thread. When you actually receive a reset thread that is constructed correctly, the TCP connection will terminate. Okay. this one, what happened is I must actually open up the user one and tell it into the victim. Right, for my case, my user one is FM. I'm going to open up the Wireshark first. Again, sniff the packets of the BR interface. Tell it to the victim. Alright, tell it to the victim. I run some command. Write any comment. Then don't type anything more. Alright, go to your Wireshark. Look at the last. Alright, look at your last this packet. Then I'm going to copy the port number, like the source port. So this packet is actually 10906 sending the acknowledgement to the victim, right? 10906. Because just now I tell it from 10906 to the victim. Alright, I type some command. So there's acknowledgement from 10906 to 10905. I'm going to copy, alright, the source port. So I will right click the source port, copy the value, paste it inside the destination port on here. Then I will copy the acknowledgement number. You scroll down, right, in the TCP part, there's an acknowledgement number. Right click, copy value, right, the last packet. Copy it to the sequence number here. Save it. Alright, save this one. Let me open another tab. So I'm actually the VM machine. So the file is actually called let5task2.py file. Now remember at this moment in the telnet don't have any more commands. So it should actually remain at the last packet here. Then from here I actually run the Python file. I run it. Oh. Sorry, the sudo command. I run it. Go back to here. Where I will see this connection closed by forward code. So the telnet connection is being terminated. Alright, terminated. So look at the last packet. The last packet here. You see it's actually a reset packet. Okay, you see this is a spoof packet that is sent out by the command. This is a spoof packet. Alright, I stop a while then and do it again. Because every time you do it, you got to manually change the sequence number and the port number. It's going to be different. So what do I do again? First, I count it from 10906 to 10905. Right, I count it from 10906 to 10905. I open up Wireshark. I look at the last packet just now, which is actually the last packet just now. It's 1, 2, 3. Let me just remove it. So this is the last packet just now. Okay. When you log in, after I log in, I type a few commands. Then I stop. Don't do anything. I stop. Don't do anything. Then I look at the last packet in the Wireshark. It should be an acknowledgement. Alright, it should be protocol TCP and acknowledgement from 10906 to the victim. Then I copy the source port number. I copy the acknowledgement number. Okay. I copy the source port to the destination port here. And I copy the acknowledgement number to the sequence number. Alright. So that when I send the reset packet, the victim OS will not think that there's some issues and don't actually allow this packet. And the key thing here is there's a reset track here. Alright, there's a reset track here. So every time you do this experiment, you got to change the destination port. You got to change the sequence number based on your Wireshark. And my connection is I telnet from 10905. Sorry, I telnet from 10906 to 10905. Right, let me do this thing again. First, I have this piece of code. I'm going to change the destination port and the sequence number. Okay, this is my this is my 10906. Then I count it 10906 to 10905. I log in. I run a few commands. I stop there. I go to my Wireshark. I go all the way down, look at the last packet. Right, it should be an acknowledgement to the last telnet, data right up here. It should be an acknowledgement from 10906 to 15. Then in here, I will copy the source port. Just right click, copy value. I copy the source port to destination port because now the direction is reversed. I go back to Wireshark. I look at the acknowledgement number. The acknowledgement number should become the sequence number. Alright, so it's because the direction is reversed. So I will copy this acknowledgement number, copy the value, paste it on the sequence number. Save it. Alright, save it. Then I run the Python file in the VM. You can run it in the attacker machine also. Alright, I run it in the VM. the sudo command first. So when I run the VM, when I go back to check my 10906 machine that is already telnet to 10905, you will see this line. Right, connection closed by foreign code, and the telnet session is terminated. You got it? Anyone has issues? Very sorry. Help each other if you have problems running the experiment, let me know. So we have a break. Then the next one is actually launching the attack automatically. So you could actually think of it, how we actually do the attack automatically. So later I will post a code, alright, to the Moodle that you can try it out also. But in the meantime, you may want to think of this thing. If yours is not successful yet, then you may want to try it out more. Maybe I'll show you the code again. This is a manual method. Right, so we go forward, then after that we come back and look at the auto part, then we move on to your task form.
Your preparation for masters. What?
I'm only at chapter 3.
Oh, the was a plot cycle, right? The CBC, ECB, CBC, and then what else? OFB, CFB.
I just started chapter 3 already.
That one. Actually, that one. ECB is the simplest one, along with CTR. CBC quite easy to understand also. Chaining.
block.
So CBC is like you use the previous block for your next input. CBC. ECB is the only one that is not secure because the mapping is straightforward. OFB, CFB is a bit hard.
So I really don't know what will be tested.
Yeah, but in the past papers, Xiong will give us like it's I remember it's CBC. Past papers,
You need to show like how it works, right? Like the sequencing.
But I'm not sure because the sub-paper that I get from the internet is us the advantage and disadvantage. When you use this more, what is the advantage, disadvantage?
Only comparison.
Yes, but there are some questions they ask you to like.
Do you think they will ask you to like decode using the
Wow, that one I don't know. I don't think they ask you to write code lah.
No, not record, like decrypt.
I think decrypt, I think you must know lah. For CBs.
Like the last number goes to the front.
Yeah,
Skip one. Something like that.
true. If you know how to encrypt, then you must know how to decrypt lah. That's the logic, right?
You need to go back to the lecture again.
But actually, there are some YouTube videos that explain the process, and they also have the more complete diagrams. AS I just read just a glance only because I don't think they will like test the AS algorithm lah, because there's so many parts. For me, like most likely the first test will come out is RSA, L-gamma, and then key crypto systems, whatever it is. And then Shamian. Shamian secret saving is the step set.
Super increasing asset.
Yeah, the super increasing step set. And then the standard ECD and the cost exponentiation. Because we really keep mentioning that one, right? Cost exponentiation and the
Xiaomi secret sharing.
RSA is similar what we did. It's actually the same what we did in Math 221. Al-Gamal is a bit complicated, but not so complicated, I see.